Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in bonus weeks and we're actually in week number 67 where I'm talking about implementing host monitoring in the Go programming language. So in this lesson, we'll review the differences between Python and Java and Go code, both in terms of how they are built as well as what the code looks like for doing host monitoring. We will look at how we start our monitoring, avoiding doing host monitoring, and then how we actually run monitoring using Go and how that shows up in the user interface. We will be looking step by step and line by line at the code that actually implements it, the Go code that actually implements getting hosts from our Quokka Prime server, pinging hosts using ICMP ping methods, functionality from the command line, and updating that into the Quokka Prime database, and how we use Go routines, which is the concurrency mechanism in Go. They're different than threads and async IO and stuff, and so we'll see how that is used. So let's get started. So let's start our discussion and investigation into this host monitoring code in Go by first looking at the implementations of host monitoring in Python, which is what this is. In Java, you can see there's multiple files here because we need to do different classes for all the things that we want to do. And then back in Go, you can see there's just one file here. So you can see everybody has imports. We've defined them in Python, Java, and in Go. One thing that you will notice if you happen to attempt to do this is Go, when you save the file, will automatically sort your imports. Now, this is a Google thing. I have friends who've worked at Google, and I've read also it's one of their coding standards is they sort their imports in alphabetical order, rather than doing them logically, as I've done a little bit of anyway. So just so you're aware of that. Anyway, moving on. Here's the get host function in Go. Here is my monitoring class, which has in it a get host function. And over here, I have get hosts in Python. So let's start with Python, which you may be the most familiar with. It's a pretty straightforward function. All I am really doing, and I do more stuff in the Python version because I'm trying to make it more real. I've taken shortcuts in Go and Java. But basically, I do request.get, pass in the URL. You can see this is my URL, and I make that request. If there's an exception, I print something out. If the response code is not 200, I print something out. Otherwise, all I need to do to return the information is I say return response.json. Now in Java, you'll recall we have multiple classes defined. So I have a class for all the different things that I'm attempting to do. And within my monitor class, I have a function. Actually, it's called a method because it's within a class. I have my method called getHost, which is analogous to the thing that we have over here in Python, getHost, and the thing that we have over here in Go. Now, the return code you'll see is on the left. I'm not going to go line by line, but I just am pointing stuff out. This is the return value. If I said code, my apologies. This is where my return value goes on the left of the function call. Over here, my function definition, the return value is on the right, which is the way that other languages do it. So you just have to get used to it. You notice in Python doesn't really care. Whatever you want to do, just return something and we'll deal with it. So remember, these are statically typed. Over here, that's why I have to give the exact definition of what it is that is getting returned, whereas in Python, everything just gets assigned to a variable and we deal with it. So going through this really briefly, I've described what we did in Python. Over here in Java, we were able to make an HTTP request. once we made the HTTP request and created a client, then we were able to do a send, and this is the request is actually includes the URL, as you can see over here. So that is where I make my request. I have an exception where I catch it. Here I do the status code. Now, if you'll recall, one of the more annoying things about Java, at least the version that I'm familiar with it, and as of this moment when I'm doing this video, is that, and let me show you this. Do you notice this is my JSON handling stuff? It doesn't start java.net or whatever, java.json whatever. It's in this other package which I had to import, and remember, it made my running quite difficult when I try to run Java. I hid that from you in the class, but if you do look in that class, I did have a very long Java statement for running it where I had to import all of these classes. So doing the JSON was a little bit of an issue. I have this mapper that I had to create, etc. So let's look at Go. Now that we're here, we finally arrived back at Go. Here I am going to declare my function. This is the return value. I'll go over this in more detail a little bit later on. What I can do, there are actually these helper functions called HTTP GET, and there's also an HTTP POST. Ironically, there is not an HTTP.put that I can use. So when I write stuff to my Quokka Prime server, I need to do something more like what we did over here with a client and then making a request. But here's my GET request. You'll notice what happened to all of the exceptions. Remember here, try except. Over here we have try catch. There are no exceptions in the Go programming language. If there is a failure, then you are expected to deal with it via the error codes that come back. So you will get error codes rather than the throwing of exceptions. And you can argue, you might argue that this makes it look more cumbersome and ugly. You may say, well, I kind of like the way that this looks in both Python and Java. You may say over here, well, it is ugly and it's much better to deal with it here where I deal with the error code. Whatever, that's just something to be aware of. So here I do my get, and now that was fabulous. Now the only problem is what I need to do is I need to get the body back from the JSON body back from my GET request. And this actually turned out to be a significant amount of work. I had to get it into the form of something called this io-util.readall, and then I needed to do a json.unmarshall. So this code right here, just if we're comparing stuff, let me see if I can highlight it for you. This code right here is the same basically as this one line of code here. And if you want it to look a little bit better, that's the equivalent of this code here. So, and maybe I will tell you, I have only been involved in Go for a week. I've tried to scour the internet for the best ways to do things, and I've tried to come up with the simplest version. It could be that I'm missing something, but at this moment in time, I'm not sure that I'm missing it at all. So basically, this is to get the response body into the form of bytes, which I can then do unmarshall for. But we'll go through that when we go into this in more detail. I just kind of wanted to give you a general idea of a comparison between the three languages. So what I want to do first is show you the Go host monitoring along with the rest of Quokka Prime running. So in order to do that, I'm doing what I've done before. I have my 3 tabs here. This tab is my user interface, which is up and running. I have my monitoring, which is not running, and I have my Quokka Prime server, which is also not running. So what I'm going to do is I am going to run my Quokka server. So now it's waiting for requests. There's no monitoring going on. And if you were to look up here, you will see that my last heard is from 8:57. You can see it's 9:03 since we do polling roughly every minute. You can see that I'm not doing any polling right now. I'm not doing any monitoring, and you can certainly see nothing's going on here right now. In fact, the only thing that you see, I'll click refresh hosts, and you can see I did refresh hosts. Here's my get of hosts, and so that's all well and good. Now let's go over to monitors. Let's look at my run monitors application, and in run monitors application you can see I've commented out the line that does host monitoring. So I'm no longer doing host monitoring. I am doing port scan and device monitor and service monitor. So those are going to begin to run as soon as I run this. So I'm going to say /run monitors.sh, and you should see these start to run. And if we come back here, you'll see a bunch of stuff going on at the Quokka server. Now what we don't have is host monitoring. If I was to go to devices, let's look at devices. These are both down for some reason. Maybe we're still in the process of getting information from them. Services is always reliable. So let's see what my services last heard. Here you can see 904, 904, 904, 904. So services is definitely getting polled. I'm not sure what's going on with these Cisco devices. I suppose it could be something wrong with my system as well, but devices are not updated. But the thing that we're interested in is hosts, and you can see hosts are not getting updated. So what I'm going to do is I'm going to start my Go host monitoring, and we will see these host values get updated. So the way that I run it is I say go run. Now, one thing I did want to point out, you see I'm doing go run here. And remember this nice description that I gave of the difference between compiled languages versus interpreted languages. And we looked at how Python code is done and that it is implicitly compiled. Java code, I have to explicitly compile it. And my Go code, I have to explicitly compile it. And you may say to yourself, well, I'm not seeing you doing the compilation. What's up with that? And what's up with that is the fact that here, run is going to do both a compile and a run step. So it's doing it all for me. So let me start to run that, and we will look at the last heard value that we see should change. I'll just do a refresh. It's still at 858. I'm going to go do this, and assuming that it's running correctly, I've gotten the host. It is very verbose. This is just how I wrote it out. I am using effectively multi-threading, except it's not using multiple threads. If you look here, you'll see that hasn't updated. The reason it hasn't updated is my time has not refreshed. So let me do a refresh and see if this makes a liar out of me. Nope, it's actually true. 906, 906, 906. So these have all been updated. And so we can see that this, at least on the surface anyway, seems to be working. And I'm attempting to calculate the response time. I can't remember. I think I found that I'm doing the response time a little bit differently in the way that I grab it, and it's supposedly a better way that I'm doing it. So these values may not be the same as they were before when I was doing it via either Python or Java, but hopefully this is a more realistic value. Anyway, you can see this percolating along in the background. Every minute it wakes up. You'll also notice that it does everything like instantaneously. It goes and gets everybody, and it updates everybody all at once. In fact, when you look down here at the bottom, you'll see, well, there's a bunch of errors at the bottom. If you recall our multi-threading, remember that when we were doing multi-threading, all of the successes immediately came back, and then a couple seconds later, the errors came back. And so that's what you're seeing here. All of these are representative of good and successful requests, and the last ones to come in are these error ones. So yeah, let's take a look at the code to see how that works. Okay, let's get a high-level overview of the code that implements host monitoring in Go. We talked about imports a little bit. You can see I have a function called getHosts that's going to return some values. There's a function called pingHosts. There's a function that we're going to get response time. You can see that's a regular expression where I'm going through and extracting the response time from my request. There's update host. That's where I'm going to call back into the Quokka Prime server and update the host with the new availability and response time. And like with other languages, here at the very end, I've got my main function. And the main function, if we're looking at it, what does it do? It does a get hosts. And as long as I've got hosts, then what it's going to do is it's going to do this for loop right here. It's going to go through all of the hosts, and it is going to do a ping host. And at the very end, it's going to wait till it's done. Just so you know, ping host itself, if I scroll back up here, the last thing that it does is it updates the host. So when I do ping host, maybe a better term would be ping and update host, but that is basically what's going on there. So pretty straightforward. It looks pretty much like the Python version in terms of what it does. Now let's look at it in a little bit more detail. Okay, so let's look at our main function here for monitoring hosts. Now, in case you're wondering why this is a little bit different than what you may have looked at a couple minutes ago, I did simplify it a bit and reorganized it, but it's fundamentally exactly the same stuff. So let's go line by line. First thing here, what's this for loop? Well, in Go, you only have one looping construct, and that is the for loop. And if you want to do something like a while true, then this is what you can do. So this is basically going to loop us forever. There's no conditions on this. And as you saw, perhaps you saw or perhaps you didn't, the way that I stop this is I just do Control C, which I just did there. So I don't have anything special way to stop this. So this is my for loop that's going to loop forever. The first thing that I do is I call get hosts. Get hosts, as you recall, just at a high level, get host is going to go make this HTTP request, and then it's going to get the JSON data. It is going to unmarshal that JSON data into the form of this thing that we're calling map hosts, and then it's going to return that. So this is going to return all of my hosts. Remember, the data structure for this is the same as it's been for all time when we implemented this, which is that it's a dictionary that has host name as the key and host, the entire host object, as the value. And that's what we've gotten back. Now, what we're going to want to do looking here is we're going to want to call this thing called ping host. But we're going to want to do it in a concurrent manner. In other words, I want to do all of my ping hosts all at once. And how can you do that? Well, one of the things that they advertise with respect to Go is that it's very good at concurrency. So I do not need to explicitly use threads or processes or async IO as we do in Python or in other languages. What I can do is I can do what they call this a Go routine. So basically I take a function. That function is called ping host, which is what this thing is right here, which, as you won't be surprised, it executes a ping. It's going to run it in a concurrent manner. So what I'm going to do in this for loop is I'm going to go through every host and I'm going to call ping host with that particular host. So I'm going to do these all at once. So let's look a little bit at the mechanism that we use for concurrency. Now, one of the things that we do for concurrency is I want to wait till everything's done. I can't just start them and then I don't know when to continue. So I want to wait for every single one to end. And to do that, I use what's called a wait group. And all we do with a wait group is I declare it here. I add one of my Go routines. I'm not adding it specifically, but I'm adding one item to my wait group. And then I say Go ping host, and I pass in the whole wait group. And then what's going to happen within ping host is when my ping host is complete, it is going to be done with this particular go routine. And so that will allow me to call at the very end, wait, and this will wait till all of my go routines, that is all of these magical concurrent execution instances that have been started, it's going to wait for all of them to complete. Now, as I've told you, I'm 1 week into using Go. This seems to be the best way to do it. I've not run into any issues with it. So it's certainly a good starting point for those of you that are interested in becoming Go programmers. There may be other mechanisms for doing this, but this is what I have chosen. So that is this code that we're looking at right here, where we are initiating all of these requests to ping hosts, and then we'll wait till everything is done. At the very end, I'm going to just sleep for 60 seconds, and this is the one of the ways that we can do that is calling time.sleep, and I pass in 60, and then the units are seconds, and this is how you do it in Go. That is my main loop. Next, we're going to look and see what ping host does. Okay, I lied. We're not going to look at ping host because we haven't yet looked at get host. So let's see what that does. Now we know in general what it does because I've told you what it's basically going to do is it's going to go make this HTTP request, and then once it has gotten the data, it is going to return them. So let's look at the code that does this. First, I print this out, print out what I'm going to do. The next thing I'm going to do, remember, this is a helper method that I can call HTTP get. All I need to do is pass in the URL exactly as I want it. One of the things that we'll be doing, remember, there are no try catch or try accept or any of that stuff. What we do is we get back 2 values from our request. Not only do we get the response back, but we also get an error. And if the error is not equal to nil, then we know that there's an error. We print it out, and then we return nil as our hosts. And this right here, this statement, defer response.body.close, defer basically says when I'm done with this function, I want you to close this thing right here that I'm going to be using. So instead of me having this code right here down at the bottom, which is what we have often done, defer says, okay, when I'm leaving, this is what I want you to do in cleanup. So I haven't seen this in other languages. It may exist, but it's kind of a handy thing. And that seems to be the pattern of the way that Go programmers do it. Now, the next thing we need to do is we need to take the response data and put it into the form of map hosts. And the way that we do this, I'm not going to go into all of this detail, but basically we're going to read the response body to get it into a byte format. So we need to do this. The body itself is not in byte format. This gives it to us in byte format. And once we have it in byte format, then what we can do is we can call Unmarshall, Jason.unmarshall. Jason.unmarshall is going to take an array of bytes, which is going to be the JSON byte data, and it's going to translate that and put it into this variable that we need to create and define, called whatever we're going to call it. In my case, I called it map host because it's going to be a map of the hosts. I could call it anything that I want. Looking back at this, I might have called it just hosts, but however we do it, it's going to be returned as map hosts. If you recall, the way that we receive it is we actually call it map hosts as well, and then I go through and iterate through that, and we'll look at that that for loop, which I haven't described in any detail yet either. So that is what's going to happen. You can see here that basically what I need to do is I need to create this variable. So this is both defining and creating my variable called map host. Now look at this thing right here. Make is going to create this instance of the variable for me. this stuff right here, what is all of that? Let me go and we'll think about it left to right, because this may look like a bunch of gobbledygook. The first thing is this. When you declare a map, if you recall from our device that we did last week, the way that you do it is you say map, and then you say the key, the type of the key, and that is string, and then you say the value. All right? So think of it this way. Don't get confused by all this stuff. I'm saying it's a map. This is the key. This thing right here is the key. And the thing that comes right after it is the value. So what is the value? You can answer that for me. It is yet another map, okay? So basically, if I'm doing this in Python language, I would say it's a dictionary with a string as a key, and the value is another dictionary. But we're in Go, so we call it a map. And the map, I need to specify the type of the key. It's a string. And the value, the type of the value is this thing right here. So let's, again, deconstruct this. What is this value? Well, the value itself is going to be another map. Remember, this thing that I'm going to highlight right here is going to be my host object or data type in our Quokka world. This is going to be the host name, the string is going to be the host name, and then the value is going to be this thing, which is a host. And a host is basically a map with a string. That string will be things like the IP address and the host name and the availability and the response time. And the value normally is a string. So for like host name and for IP address and even for response time, I'm storing those as strings. However, I do have one value in there that is not a string, it's a Boolean. And therefore, the idiom or the pattern, the thing that I tend to use is I'm going to call that thing an interface. Now, you don't need to understand all of the deep details. We don't have time to describe the deep details of what this means, but the general idea is that this data that's associated with my host, remember, this is my host and key, so it will be host name or IP address or availability or response time or last heard. The actual value is going to be some type of data, but it's not all the same type of data. And this is the way I found people in Go tend to deal with this. And what this means is that in certain situations, I will need to coerce it into being a string. So let us go and look at this. This is my map host. Now this is something that's new, and when you get into Go, we don't have anywhere near enough time to talk about referencing addresses versus the actual value of variables. But this ampersand sign basically means the address of. You'll see this in other languages such as C and C++. When you declare a variable, you may want to refer to the actual value sometimes, and sometimes you will want to refer to the address or the reference. And that is what this is doing. It's passing in the reference to map hosts into this json.unmarshall. And what it will do is it'll take body bytes and put it into map hosts. So that may be a little bit confusing to you. That's okay. We're going to return something that's going to look like this, all right? It's going to look like this right here. That's what my map host is. And if you recall from our function, when we do get host and I specified the return value, you can see it's highlighted. That's what this thing's going to be. And when we look down here at our map hosts, remember we don't have to declare it because we're declaring it by doing :equals. If we just did equals, we would have had to declare it earlier, but this is doing both the functionality of assignment of the value of get host as well as declaring this to be, as you can see, the tooltip there is highlighting what its type is. It is a map let's see if I can do this. It's a map with the key of string, and the value is another map. So that is this part here on the right is going to be my host. A host is a map with the key of string. Remember that string is going to be host name or IP address or whatever. And the value is going to be interface, which means it can be anything, and I will specify what it is when I need to. So that is get hosts. Okay, now we're going to look at ping hosts. So this is my ping host. Remember, we're doing this in the context of doing it, invoking it as a Go routine, and therefore we're specifying and passing in the wait group that we're waiting for. And we've added one to the wait group, and what's going to happen in our ping host is that we are going to, at the beginning, we're using that defer keyword again that says, when I am done with this function, I want you to call waitGroup.done. Remember, we passed in waitGroup. And so this is how keeping track of functions that get started as Go routines, and when they complete, this is how we're doing it with this wait group. So let's look at what happens. There's not a ton of code going on here. This is the main line of code. This is actually the same as we do with Python when we execute a command. Now in Java, we had an easier thing. We could call isReachable, and that would automatically do an ICMP echo to the device or host in our situation. In this situation, we are needed to explicitly execute a command, and this is the format for executing a command. We specify the command, and these are all of the arguments that we pass in. I did it the same way I did it, I think, in the original Quokka. Now we specify what is the name of the actual thing that we are sending the ping to, and that's what this is. So we passed in host. Remember, if you recall, this is the piece of that very long description of a data type that we were doing before. If I was to go up here and we were to look at this, do you see this whole thing? The thing on the right is what I said was basically a host, and you can see that it's even slightly highlighted up there. So that is my host definition of the data type for my host. Now, when I come down here to my host and I want to execute, I want to tell it that the thing that it's going to ping is going to be my host, and the key is going to be in quotes host name. So the actual key is the string host name. That's what we've done in Python over and over and over again. Now, here's something that you may not be familiar, I'm sure you're not familiar with, and I wasn't familiar with until I started using interface. Because we said the type of data is interface, Go does not know the type of the data. And so if I were to leave this off, then Go would not know what to do with that. You can see it's put the red squiggly line underneath it because it doesn't know that it needs to coerce it to be a string. So if I put it back on, then Go is happy and it says, okay, that's a string. Now you may look at the line above and say, hang on just a doggone minute, why didn't you need to do that up here in the fprint line? And the answer is fprint line knows it needs to coerce everything into a string, and so there's no question about what data type it should be. However, down here in this situation, I need to coerce it to a string. Now the last thing is, if I want to get the output, if I want to run this command, if I just do exec.command, it creates the command. If I want to run it and get the output, I need to put .output on it. And this will give me two return values. One will be the output and one will be the error information. And so if the error information is not nil, that means I got an error and there's a problem. That means I need to say that the availability is false, and I'm going to print out this thing that you've seen in here. Let's see if I have one. Error pinging host exit status 1. I have no idea what the exit status 1 actually means, but that is what happens when we get here. If error is actually nil, in other words, it's not equal to nil, then I will set availability to true. Notice that this is a Boolean. It's not in quotes. The true is not in quotes. The response time, I'm going to call something to get my response time. That's down here. We're going to look at that in just a second. And then the last herd is this is how I get my time and coerce it into a string. Now it's going to give me a lot more data associated with that time than I'm actually going to print out in my last herd. I only am printing out the last 3 characters after the seconds. There's a bunch more stuff. And so if you were to count this, you would say, oh, that's 23 characters or 22. Basically, we want to go up to but not including 23. And this, you'll be familiar with this slicing of a string, because that's exactly how we do it in Python as well. So let's take a look at getting the response time next. Okay, let's look at how we get the response time now. Get response time is a simple little function that we have here. It takes the ping output, so it's the output from the ping, which is going to look something like this with information like this. So that's basically what we're going to be looking at, and we need to extract the response time from that. Now you'll notice that the response time has this last thing, which includes minimum, average, maximum, and whatever that is, something deviation, I suspect. We're going to look for the average. That would be the second item here, and that's what we're going to use as the response time. So how are we going to do that? We're going to use regular expression. So we're using regular expression functionality, as you can see, that's provided within the Go programming language. And this is going to be similar to what we've done in Python in the lesson on regular expressions. We're going to provide a regular expression. This is my regular expression right here. And so if you need to learn about regular expressions, you can look it up online, go to that other lesson. But basically what I'm doing is I'm looking for min, max, av, mdev, space equals space, and then some numbers separated by a dot and some more numbers, and then a slash, and then the same thing. You'll notice I put these parentheses around things. That allows things to be grouped. I call find string submatch, and what that's going to do is it's going to give me a slice, which is like a Python list or an array, and it's going to give me multiple values, multiple entries in this slice. Remember, yeah, we haven't gone into great detail, but a slice is a higher order data structure that has more functionality than array. Think of it as an array or a list if you want to think of it as a Python type thing. It's usually printed with square brackets around it. So this is going to have multiple items in it. The first item is going to be the complete match of the entire thing that it matched. The second thing is going to be, the next thing is going to be groups. And so since I have 2 groups, response time match sub 1 is going to be this thing right here. Response time match sub 0 is the whole thing that was matched. Sub 1 is going to be this one, and sub 2 is going to be this thing right here. And if you recall from our response time output, this is the first thing that we match, and this is the second thing that we match, the second group that we match. So that's this thing right here, and it's that second actual thing that we're looking at. This would be item number 3 in the array, but it's the second group here. And so that is where I'm going to get my response time, and that's going to be a string, and that's what I will return. And if I fail to match it, then I just return 0.000 for whatever reason. So that is, yeah, now that I think about it, I might have better if I return nil and then just didn't set it. Because as you recall, you may or may not recall, the way that our Quokka prime works is it only sets things that I set here. So if I were to omit the response time, it just wouldn't set it. Yeah, anyway, whatever. This is what I'm returning, the second item, which is going to be the second thing that's matched, the second group here. And that is basically going to be this value for that, or let's see, where's some other ones? This value in milliseconds, what the time was. And that is my get response time that gets put into host response time. Okay, the last thing we're going to look at is update host. Remember, that's the last thing that we do after we've pinged the host and gotten all of this information about availability, response time, and last heard. So let's look at update host. Now, let's have a look at what we're going to do here. The first thing that we're going to do is we are going to convert that host object. Remember, the host looks like this. It's basically a Python dictionary. In Go parlance, it is a map with a key of string. That key is going to be IP address, host name, availability, response time, etc. And the value, again, I'm specifying it as an interface. It will be a combination of strings and that Boolean for availability. And what I need to do is I need to call Jason.Marshall. This is an easy way. All I really needed to do is call Jason.Marshall and pass in my host, and I will end up with my JSON version of that host data. Now, you'd think it would be very easy. If you recall, what was it like when we did get hosts? How difficult was that? It was actually pretty trivial. That's all I had to do in order to get hosts. Guess what? You would think that there's an http.get, there's an http.post, there is not an http.put. Now, as you can imagine, some people have written open source stuff that will implement that, but we don't actually have that. So we're going to have to do it the more difficult way, and that way is going to be what you're going to see here. And this is similar to the way that you saw things work in the Java world. The first thing I need to do is create my HTTP client. The next thing I'm going to do is I'm going to create my request. And I do that by saying http.newRequest. And now I give what is the method going to be. Now, just for grins, I could have done the get exactly this way as well. But I had a helper routine, so I used that. There is not currently a helper routine for a put. I'm not sure why. So this is what we have to do. I have to create a request. So this is my new request. It's going to be a put request. This is what my URL is going to look like. HTTP localhost 5001 host name, and here's my string host name. And again, I need to coerce it with this .string notation at the end. And then I'm going to pass in what is the data that's going along with this put. And then this is where I'm going to put my JSON host. Now, you recall it was a lot easier to do this in Python. What I need to do here, this is just what you have to do. I'm using this primitive facility that's part of Go called bytes, the package that allows me to do something called a new buffer. And in that new buffer, I'm putting in this byte data, which is JSON host. Once I have done that, then I need to set my request header to application, the content type to application JSON. This is just an HTTP thing. Once I've done that, this is my code right here that is actually going to do the sending of the request. So I'm taking my client, I'm calling the method do, and I am passing in the thing that I just created, which was my request, and that I modified with content type equals application JSON. That is how I do my put request. If it fails, I get error updating host and there's a problem. If it succeeds, but my response code is not 2004, then I print out something that says I got an unexpected status code. But 2004, as you recall, from your HTTP is a status of okay, but don't expect any data back. And that is my updating of the host. This is all I do right now. I've modified this, taken some stuff out, updating host. So when you see that, every time, these are for errors when it was bad. Here's a situation where I think I had data, updating host, etc. And that's what I'm printing out up here at the beginning. So that is how we update the host. And that completes our walkthrough of all of the code for host monitor. As an aside, you'll notice I didn't do discovery. I decided that there's enough going on and it's taking long enough to just describe all of this stuff. I wouldn't go into the discovery as well. But as you can imagine, it would probably be very similar to what our monitoring is. We would do a wait group, and instead of ping host, I would do a ping host, but I would be passing in an IP address. I would probably call it discover host. I'd pass in an IP address that would I would do it 254 times for every potential IP address, and I would do that concurrently. But I didn't do that in this. Probably you have enough Go bouncing around in your head now as it is. So that is how we do host monitoring in Go. Okay, let's remind ourselves what we discussed in this lesson. We started off remembering about the differences between Python and Java and Go code, Go, which is like C and C++. We also looked at the code that was written for host monitoring for Python versus for Java, where you have multiple files, versus Go. In addition to that, we looked at what it took to start and run Quokka with the monitoring being done only for devices and services and port scans, but not for host monitoring. And then we ran host monitoring for our Go application, and we looked at how it updated the last herd. Then we looked at the code a bit, and we examined the actual Go code. Let me get rid of these quickly. The Go code itself was consisting of getting hosts, which is something where we go out to the Quokka server and do HTTP requests. We looked at Go routines that we invoke with this ping host function. Ping host is going to actually do the pinging, and it's going to do it concurrently because we have a wait group. We will wait till it's done, and when we're done, we'll wait 60 seconds. And in the code, we looked at get hosts and how we make an HTTP GET request. We looked at ping host and how we execute a command. We extract the response time from that. And the last thing that we do is we update the host, which is where we go out and we have to do a little bit more work because we have to create a client and a request and then do client.do with the request. And that is the Go code for host monitoring in a nutshell. Hopefully that made at least some sense. If you do have questions, let me know. In the meantime, thank you so much for watching and listening.